this will be also recording for YouTube. Sorry. Anyway, so what is RSZ? Well, those are values, some values use Intel ECDSA process. So we will start asking us what is ECDSA. Well, these are also annotation for elliptic curve digital signature algorithm. Let me send you one link. You can check all these by yourself in this page. So let's go back here. So this ECDSA is elliptic curve digital signature algorithm. I don't know if I write it correctly. Anyway, it's algorithm. Anyway, let's continue. So let me copy this to another page. Okay, so let's imagine that someone else need to make a digital signature. There are some algorithms for that. There are some algos to do that, like RSZ and ECDSA. There are another more, but these are only a few examples for that. So in this case, we are talking about this. So this person need to make a signature. This signature for a message. Hi, August Delioglu. I don't know how to pronounce your name. Thank you for joining the chat. This will be recording also for YouTube. Anyway, this person needs to make a signature for a message, and this person use ECDSA algorithm to do that. So let's imagine this person need to have a private key. Okay. Need and a message to say. Okay. Okay. Let's do this with an example. Wait me, please. Where is that? I choose. Well, let's do generate. Okay. Sorry. The message is hello world. Okay, wait me, please. Okay. So this is the message, and let's to create a private key. I will do that with a command, khen, sorry, khen is inside of my ECC tools repository. Khen, just generate one key. We only need one value. We don't need the others. Well, let's copy only this and the public key. Okay, wait a minute. Este key is, let me change this. Private key. Public key. We don't need the public key right now, but let's to have it. So, in order to make the signature, we also need we need to calculate the hash of this value of the message. Is the hash of the message. Let's use share 256 soon echo hello world and minus n. Let's check. Okay, let me. I will move this to another place. We don't need this right now. Anyway, message is hello world, and we need the hash of this message. Hash share 256 is this value. Well, this is use an example to corroborate that value. I also did one program to do that. Let's do. Okay, wait a moment, please. We also need to generate a random key number. This is not our private key. Let's copy this. Copy to here. This is the point 2. The point 1 is the hash. Point 1 is hash of the message, right? Okay, guys, please feel free of ask me any question if you have. I will try to make this. This is for you. I will try to reply your questions. Okay, so okay, let me do something here. Okay, we need another number. Okay, let's put one comment here. This key value is not our private key. Okay, entonces we need to generate another number. So let's do that again with khen. Let's copy this value for this example. So k is equals to this. It's a random number. So okay, let's continue. We need to calculate some random point, a random point from our previous k value. We need to do a scalar multiplication, key multiplied by our generator point, and we only need to take its coordinate r. So let's do this manually. But also, well, actually, this is the public key. This is still x value. Let me copy public key compressor. Yes, public key compressor. Okay, but let's do that just to corroborate this. Calculate from key. If you check, this value is the same of this value, public key compressed. So we only need to take this value as air value. But as I said before, I make one program, generate RSZ, and this program asks for their private key. The private key is this value. Let's copy and paste here. Also, it asking us for the random key value, and this is sorry, this is not a random key. This is a random key value. Let's copy this and paste. Copy and paste here. What is the message? The message is hello world. Okay, this program also calculates the air value. Let's copy this to our notepad++. Okay. Okay. Check. The public key without the prefix 02 is the current air value. Also, the seed value is the same that we previously calculate with this command. Let's do copy. What is the command? Here. Here is the message is the same. We calculate this, and my program also do that. So, what we need to complete the signature process? The signature process need to calculate a proof of the signature. This is as signature proof. So, okay, let's clarify something. What is RSZ? Those again are values in the ECDSA process, right? So R is the its value of K multiplied by a generator point. It's forget this. So this is equals to 1 point, and we need to take its value. This is R. So S is a signature proof, and C in this case is the hash of the message to be sent, right? Okay, so this is the equation for this for calculate S. I already have write it here. So this is the equation. So what's happened? This equation has some values. Let me amplify this part. Where is that? Okay, this is no less. This have the previous K value, but inverse is in his inverse value. Also, well, this H is our C. This H is our C value. Also, it have R and the private key. So what's happened in this equation? This value S and this value R is public, but we don't know what is the K value, and also we don't know what is the private key. But what happens if let me write this. So in this equation, k and private key are unknown, unknowns values, right? What's happened if we can tell key value? If we can solve this k value, we also can rearrange these values to solve what is the private key. Right? Welcome to the chat. Please feel free to ask me questions anytime. So what happens if we can guess the k value? Replay. We can solve the private key. So the equation to solve this private key, if you already know the k value, is the next equation. You can do actually copy this value. You can you can corroborate it by yourself. Okay, with me, right? Thank you, Ryan. I don't know if actually it's reflected on your side. Thank you. Sorry for that. Okay, you can correlate by yourself. You can paste this value to this side of the equation, and this k value is already inverted here. You can move this value from multiplying here to dividing here, but this value is already inverted. Okay, let me clarify something. K inverse is equals to our previous k value, but inverted. K inverse is 1 between k. So this value is this actually. But if we are going to send this k value to the another side of the equation, is s multiplied by k equals to something else, this value. So you can have the private here alone. So to do that, you need to paste this c value, subtracting s plus k minus c is equals to r multiplied by the private key. But you can also pass this r value dividing to the other side. So let's put s plus k minus c. All this divided by r, or in other words, multiplied by 1 between r, equals to private key, and 1 is r inverse. So the final equation is this. Remember, all equations here are module mod n is module n. Okay, I hope you follow me. Please ask any question if you have doubts. Okay. What's happening with the music? Sorry. Okay, let's continue. So this is the way to get this equation. Okay. So if you know the key value, you can calculate the private key. So what's happened? Let me put this. What happened? Okay. There is one weakness. If you reduce, if you use again the same key value for another signature. Okay, let's to make another signature from these same values, from this private key, also from this key value. Right, guys? Let me erase this. Clear. Generate RSZ. Private key is this value. Copy. And random value is this value. Okay. The message is live streaming. What the fuck is RSZ? Okay, let's to copy these values. Okay. So we have this is an example of two signatures that use the same key value. Message 2. And this is the message 1. Okay, sorry guys. Message 2, and this is from message 1, right guys? Message 1 is hello world. Okay, so if you check this value, our R value is the same in both signatures. Signature values, and right here also signature values. So S is different in both, and C is different. So what happens if you reduce the same K value? Let me put this, let me copy this. So this is, let me write C1, S1, and R1 inverse. Private key for values from one transaction. And let me copy this again. R2 inverse. K, sorry, guys, S2 and C2 values from let me transaction 1 here. Here transaction 2, right? So if we use the same key value for this equation, also we have the same private key. So you can copy this value, this equation, sorry, and this equation produces the same private key, and this equation also produces the same private key. So the equations becomes this equation becomes solvable. So you can reaccommodate, reorganize, I don't know how to say it, those terms, and you can solve the key value because both equations produce the same private key. You also can solve what this key value is. I don't know if you can follow me. Let me share one image for you. Sorry guys, wait a moment. For wait a moment guys. I am looking for something for you. Here. Okay. Okay guys, I hope you can see this. I bet that you already seen some equation like this. So if you can solve this equation, you also can solve this value. It's just a play for scholar children. Let me share another with me. Okay, so if you can solve these values, you will be able to solve this k value. Okay, let's do this. Let's reaccommodate these values to solve k. You need move these values with me, please. Wait. Where is my note? Okay, so you can have this. Let's develop this equation. Wait. Let's develop the equation. Sorry. Array even multiplied by ks and minus array inverse multiplied by c1 equals to array inverse R2 inverse multiplied by this and minus the same value, this value, sorry, R2 inverse multiplied by C2. Okay, let's move the k values from to this side of the equation and this value without key to the other side. So this value keeps and minus this value. Yes, and equals to this value is negated, pass here and positive, so we can omit this symbol, minus this value. Okay guys, what happened? If we use the same k value in both signatures, the R value is the same for those equations. So this value is the same from to this value is the same value. So we can simplify. Let's do simply 5 because R1 is equals to R2 because we use the same key value. Okay, I hope you followed at this point, guys. Thank you for joining. Okay, so is R inverse that multiply this value, and is minus R that multiply these values also R inverse that multiply these values is equals. Let me copy this and we can remove the number. So we have some R inverse in common. We can remove that in this way. R that multiply wait a moment. Okay, let's do that multiply K S1 minus K to multiply S2 also here equals to the same from this side C1 minus C2, right? Okay. Also in this we have the key value is repeated, so we can also move outside this subtraction. So K multiply R inverse that also that multiply S1 minus S2 is equals to this. So what happened? We can move this is being multiplied. We can pass this part dividing. So K is equals to this value. Oh no, sorry, this value between this another value. What happened? In this side of the equation, we have R inverse R in both sides of the divisions. We can also remove this because is here we can remove R because this between this is equals to 1. So let's move this and this. I forgot this multiplied sign here. Okay, guys. So if we have these values, C is public, S is public, and we don't know K, but the same K value was used, we can calculate K doing this division. Okay, well, actually it's not a division. For this example, it's a multiplication by this value inverse. Okay, I already did one program. Let me edit this program. Nano RSZ.c. Let me change these values. Wait a moment, please. those values are different from our example. Let's do, sorry. Okay, let's copy our values. R is the same for both sides, for both transactions. Let's copy S value. Let's copy C value from the transaction 1. Let's copy S value for this. And let's copy this value. Okay. Save and compile. This command is already generated, so let's execute that here as C calculate values. Okay, our calculate values are these, and let's copy these values, private key from here, and okay, so here let's remove these values. Okay, if you check, the calculate private key is still saying that our private key and the random key value is also the same. So this is why this process need to have different key values in each signature, because if not, you can't solve the private key and your bitcoins can be stolen. Well, this process also need to be sorry, I don't know how to say that. This process also need to be come on, to be done by a computer program that checks for previous key values. So to avoid to use the same. Okay, what more I can say about RSZ? Okay. So another thing, guys. Another thing. Also, if you know, if you have, let me copy. If you have two signatures from the same private key, and also you know the relationship between the key values, you can also solve the equation. Let's say equation. Let's copy these values again. Okay. Wait a moment, please. Here. Let's copy these values. Okay, let's do K1 is this and K2 is also these values, this value but K2 is K1 plus 1 or some other constant. Let's say K2 is this value. So this equation, let me copy the equation. This equation also becomes solvable for that case. Also, if K2 is equals to K1 multiplied by a number, any number, if you manage to know that relationship, that equation is also solvable. Okay, guys. I don't know if you have some doubts. Let's wait if someone asks something. I have some other links for you guys. Let's to send to you this link. This is the first link that we already checked, and you have another links to check. Okay. I don't know what more to say, guys. This is actually what I want to show you. So previously, I don't know. Let me write this. Previously, some software did not check the key values properly, or it do it on purpose. And so previously there is some documented case that use the same key value for many transactions and the private key was solvable. Yes. Okay. I don't know if you have some doubts. Guys, please, if you have something, please write in the chat. Okay, I will wait some 2 minutes here. If not, I will finish the broadcast right now, the streaming right now. let to show you the code that I use. I think I will upload this code to some Hiphook repository, hoping that you like it. Use with your own examples. Also, the code. Let me check that. This is the code to generate our values from a message. This value generate RSZ is this code. I will create some repository to do that. Also, this kind of code is already on Python. It's more easy to understand that this C program, but it's not difficult. This C program is only 90 lines of code. Okay, guys. If there are no doubts, I will finish the streaming right now. Thank you for joining. I hope this explain. Okay, one last thing. Currently most of the software. Sorry, I am writing wrongly. Software implementations already check this properly, and there are not more reuse key values until blockchain. Okay, guys. Thank you for joining today. If you have ideas, or you want some specific topic, please let me know. Thank you. Bye bye.